Okay, so you have a couple problems posted for practicing for your exam 3, and these cover multiple regression, but just keep in mind that your exam also covers time series. So make sure that you're doing your Connect homework and doing those for study attempts and really working along with the lecture video on time series, and you should be able to answer any questions that come for time series and doing your case study. All right, so there are 22 questions here, but your exam is going to be 31 questions, and we're going to take it out of 30. So let's get started. Increasing the sample size does what? Hopefully by this point in the semester you know that that reduces variability, so that leads to a narrower confidence interval. And then increasing the confidence level yields a wider interval. If you want to be more confident, you're going to need a wider interval to capture that parameter. A small p-value indicates what? That indicates evidence for the alternative hypothesis. If you had a large p-value, that would be lack of evidence for the alternative hypothesis. Which two answer choices are never the correct answer? A and C are never the correct answer. All right, so you either have a small p-value, which is evidence for the alternative, or a large p-value, which is lack of evidence for the alternative. Hopefully you're getting really good at those kind of questions at this point in the semester. All right, so the following questions pertain to data on 30 homes found on Trulia.com in Silver Spring, Maryland area. A regression was run to predict a home's assessed value in thousands of dollars from the size, square feet, and thousands, and whether it had a fireplace or not. The regression was fitted with the interaction term size times fireplace. All right, so the p-value for the F-test in the ANOVA box is 0.01. Now, first of all, where did I get that? Well, the F statistic is down here on the very bottom, and it gives its degrees of freedom and then the p-value for that F-test. And what is that F-test test? That tests that all the coefficients equal 0 against the alternative that at least one of them is not 0. So that's a significant p-value because it's low. 0.01 is low. And so we would conclude the alternative that at least one predictor is important to the model. Okay, the R-squared for regression, for this regression is 0.346, and the adjusted R-squared is 0.271. And I would consider those to be far apart. Now, if you get a question like this on your exam, I'm better now at saying I think those are far apart or I think they're close together. So if we assume that the adjusted R-squared is significantly lower than the regular R-squared, this means there is evidence of a weak predictor in the model. And accordingly, if they were close together, that would be lack of evidence for a weak predictor in the model. All right, now the p-value for the interaction term, size by fireplace, is 0.462. So what does that mean? Well, that's a big p-value, so that's lack of significance. So the interaction term is not significant. So what would you do when you don't have a significant interaction? You do the exact same thing you do with a two-way ANOVA. You'd remove it and rerun the regression. All right, what is the standard error for regression? That tells you how far off your predictions of the Y are in general. So the standard error for this regression, our Y was the assessed value of a home. So predictions of assessed value tend to be off by $62,390.91 in general. So one of these is probably the R-squared. Yep. A is the R-squared. If that was the number for R-squared, that would be the percent of variation in the Y that's explained using that set of predictors in this model. So make sure you know both of those. Make sure you're doing your practice homework that I've got posted for regression, because that'll help you nail down everything that you need for this exam. All right. Tom Shields, jury commissioner for the Franklin County Municipal Court in Columbus, Ohio, is responsible for making sure judges have enough potential jurors to conduct jury trials. One of the most challenging aspects of his job is to make sure that registered voters who receive a summons to appear actually do appear. Report percentages were recorded for 26 time periods in 1998 and 2000. The regression output below has two predictors. Period is a number starting with 1 for the first group to appear in January up to the 26th group, which denotes when the last group appears in December. Year is either 1998 or 2000, and the response variable is the percent of jurors who appear for duty. So let's pay attention to our regression output. So notice that we've got a coefficient for period, negative 0.71687, and we've got a coefficient for year, but what makes this special? Notice that we used the factor function when we ran this regression. That means that year is being treated as a categorical variable. The fact that the 2000 sitting here tells you that 2000 would be a 1 plugged into our regression equation, and a 0 would indicate that you're in 1998. So I either have that in the output for you to be able to tell that, or say it somewhere in the blurb. All right, so we're tasked with making a prediction when the year is 1998 and the period is 24. So our regression equation is 77.08 minus 0.71687 times period plus 17.8346 times year. So we make a prediction for 1998 and period 24. Period is 24 in all the answer choices. So obviously I'm testing you on whether you know how to plug in a number to get a prediction for a categorical variable. Since we treated year as a categorical variable, we either plug in a 0 or 1. And either you get it from the blurb or from the output. We know here that 2000, the year 2000, gets a 1. So if we want to predict for 1998, we need to plug in a 0 for year, because 2000 is the coefficient that it put in the output, and so 0 would indicate the other year, 1998. So A is the answer there. All right, interpret the coefficient for period. So the coefficient for period is minus 0.72. So for a 1 unit increase in the x, we expect the y to change by that amount after accounting for other variables, right? So as period, so that's our x, period increases by 1, we expect the y, the percent of sum and jurors who appear for duty, to change by that amount, decrease by 0.72 after accounting for year. So the answer there is A. Now we want to learn how to interpret the categorical predictor year. So it goes pretty similar to the quantitative predictors, but this time we're not changing by 1 unit increases. We're either flipping it on or flipping it off. So that coefficient, 17.83, tells us that for the year 2000, the percent of sum and jurors who appear for duty is on average 17.83 units, which is percent, in our example, higher in the year 2000 after accounting for period. So again, make sure you're going through your lecture notes really carefully, listening to the lecture videos and filling those in and understanding those examples, and also doing the extra practice homework that I've got posted in Canvas. All right, the p-value for period is really tiny, so this means what? A tiny p-value means it's significant. Plugging in a 1 for year and a 12 for period would yield an estimate of the mean percent, the mean y, who appear in period 12 in the year 2000. That's the second time we hit that 1 or 0 plugged in for year. All right, so some additional questions. When using a regression model for prediction, one should be concerned with what? You should be really good at this because you've been doing your Kaggle project, and that is minimizing the standard error of the regression, because that tells you how far off your predictions are, how close your predictions are in general. All right, you run a multiple regression that has a low p-value for the f-test, but large p-values for each of the predictors. What happened there? So if you have a low p-value for the f-test, it tells you have at least one important predictor to the model, but then all the large p-values make it look like that's not the case. However, we know that those p-values say that they're not important in the presence of the other predictors. There could be collinearity present. So if that happens, there could be collinearity present. And that question was ripped directly from the practice homework posted in Canvas. So again, I can't overemphasize doing that extra practice homework to prepare for this exam. All right, when is it important to diagnose collinearity? It's not really important to prediction. It's not important to the fit of the model. It is important when you're trying to interpret the regression coefficients relative to the others. All right, 17, you run a multiple regression with 2 predictors. One coefficient has a high p-value and the other one has a low p-value. What should you conclude? Here, I'm trying to emphasize that just because one of them has a low p-value and one of them has a high p-value, it doesn't mean you should just throw out the one with the high p-value. You should check out if they're collinear, and if there were only 2 predictors in my model, I would run each of the simple linear regressions to see which one looks more important before throwing that one out. So I just don't want you to jump to a conclusion that just because one of them has a high p-value and the other one has a low p-value, that only the high p-value is important to predicting your response. So I want you to say the term with the high p-value might be better for predicting the response, but we don't quite know yet until we look at them individually and consider collinearity. All right, 18, the confidence interval for a predictor's coefficient goes from 56.65 to 88.72. Based on the confidence interval, could we tell if the p-value is significant for that predictor? Yes, we can, because what's the null hypothesis in regression? The null hypothesis is that coefficient is 0. So if our confidence interval contains 0, we know that our hypothesis test would fail to reject the null hypothesis that it could be 0. But our confidence interval are all values that differ from 0. So we're going to think it's significantly different from 0. All right, Cook's D is a measure to detect what? That's a measure to detect influential observations. And remember, the HIs are what you use to detect leverage. And of course, residuals are either regular residuals, standardized, or studentized residuals. Adding a quadratic term to a regression does what? It provides a test for nonlinearity. So that p-value that quadratic term gives you lets you know whether that quadratic term is significant or not. 21, if your response is a dichotomous categorical variable, you should use what? That is logistic regression. This best subsets and stepwise regression are ways to put together subsets of predictors to try to figure out which is the best set of predictors for your model. Categorical regression, it's logistic regression. When you're trying to predict a 1-0 yes-no response, you use logistic regression. Like whether if they're going to respond to the offer or not. All right, 22, if the probability of an event is 0.5, what are the odds? So remember, the odds are the success probability over the failure probability. So P over 1 minus P. So if our probability is 0.5, 1 minus the probability is also 0.5. 1 minus 0.5 is 0.5. And so the odds here would be 1. All right, so that's it. Make sure you study, do your extra practice homework, and send me questions as you have them.